Remember back in 2019 when we got the first images of the black hole? The whole world went crazy, and that black hole was like 55 million light-years away. What if I told you that we have one more black hole that's at the center of our very own galaxy? You would freak out, right? Well, that's the truth, and that black hole is called Sagittarius A. At an international news conference on May the 12th, the Event Horizon Telescope collaboration announced the first direct photographs of Sagittarius A, the supermassive black hole at the center of the Milky Way. This remarkable achievement comes 2 years after the same group of scientists published the first photograph of a black hole. Nothing, not even light, can escape from a black hole. We can only glimpse a black hole through the bright leftover streaks of whatever unfortunate stars it's devouring. However, between us and the galactic center, there is so much obscuring gas, dust, and debris that only the longest wavelengths of infrared light can get through. Despite this, our long-wave radio telescopes were able to take the first image of Sagittarius A, which is approximately 27,000 light-years away from Earth. It possesses 4 million times the mass of our Sun, but it occupies only a small portion of the sky, about the same size as a donut on the Moon's surface. The Event Horizon Telescope, however, is a collaboration of radio telescopes from throughout the world. The EHT connects radio rays to form one massive radio telescope. This results in unparalleled angular resolution. These observations were made with the help of 8 separate radio telescopes. The EHT partnership includes the Atacama Large Millimeter Submillimeter Array, ALMA. Sagittarius A is located within the ecliptic of the Earth. In the inset, you can see where Sagittarius A is located in the Milky Way, along the night's backbone. EHT collaboration scientists also made a fly-through film that begins at ALMA and zooms in all the way to Sagittarius A. As it approaches the black hole's event horizon, the movie shifts from visible to infrared. The video can be found by searching on Google. If you decide to view it, be aware that the results can be dizzying. Videos like these are made up of hundreds of thousands of individual night sky pictures. The photos are then combined into a 3-dimensional simulation of what a tourist from Earth would see as they approach Sagittarius A. Now the question is, how did they find it? Well, it took their blood and sweat and a sacrifice to the gods. Well, not really, but it was because of the hours and hours of hard work. EHT scientists utilized a method known as a Very Long Baseline Interferometry, or VLBI, to take these photographs of Sagittarius A. VLBI compares the timestamps of the reading it gets and exploits the minute discrepancies in timing to make exact measurements of distant deep sky objects. It's similar to parallax in that we're trying to determine the distance between things that are so far apart that they don't move in the sky. Instead of following their movement, we use radio telescopes to track the arrival timings of distant transmissions. Every day, this procedure generates gigabytes of data. The EHT cleans and calibrates the data before transferring it to the MIT Haystack Observatory or the Max Planck Institute for Radio Astronomy on helium-filled hard drives. They analyze the data using supercomputers known as correlators, which cluster and average all of the readings. Astronomers attempting to capture a clear image of the black hole face a significant barrier. To finish their depiction of Sagittarius A, the scientists needed a long exposure of maybe 8 to 10 hours. However, accreting gas and dust are whizzing around the black hole at near light speed, completing an orbit in minutes. It was a task in itself. According to EHT scientists, Sagittarius A is currently ingesting 2 or more itinerant stars. However, the pace of accretion is unequal. This could explain why we see blobs of light rather than an even symmetrical halo. The blobs of light resolved into streaks of incandescent star material when they combine their thousands of frames into a video. The EHT network itself is still growing. This first photograph of Sagittarius A was created with the help of 8 observatories. 3 more observatories have joined the effort as of March 2022. Upgrades to technology are ongoing. Meanwhile, the EHT collaboration opened up their entire project when they revealed these initial photographs of Sagittarius A. The data that the researchers used to create these photos is completely public on numerous levels, according to Michael Jansen, an EHT spokeswoman. The EHT collaboration also provided their raw data as well as the algorithms and cleaned-up dataset, so anyone can replicate what we achieved from the beginning, according to Jansen. So if you're a computer and astronomical genius who is waiting to get a chance to do something that no one has ever done before, here's your chance. Combine the data, and maybe you will get a better result than the ETH itself. If that happens, don't forget to mention us in your Nobel Prize speech. You're welcome. The achievement comes after the EHT collaboration released the first photograph of a black hole in 2019, dubbed M87 after the galaxy in which it resides. Messier 87 M87 is 1,000 times larger and 1,000 times heavier than Sagittarius A. The two black holes, though, are very similar. EHT researchers intend to find out why. Now we can investigate the variations between these two supermassive black holes to learn more about how this critical mechanism operates, stated EHT scientists Kelchi Asada. Now that we have photographs of two black holes, one at the enormous end and one at the small end of the universe's supermassive black hole spectrum, we can test how gravity operates in these extreme conditions far more thoroughly than ever before. This is a big breakthrough, and now we will get a better understanding of these black holes. That's all for today. Now you guys tell us what your thoughts are about the discovery of the black hole in the comments section, and I'll see you in the next one. Until then, goodbye.